In this video, we'll be going over lowest common ancestor of a binary search tree. So given binary search tree, find the lowest common ancestor of two given nodes in the binary search tree. So the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So in the first example, we're given this binary search tree, and then we're trying to find the lowest common ancestor for 2 and 8, which is located here. And then we can see that it's 6. So we can return 6. Let's go over the dot process. For each of the node X inside the binary search tree, how can we determine if X is the lowest common ancestor? X is a lowest common ancestor if it has P and Q in separate subtrees. So for example, if we're currently at this node, we can see that P is located on the left side and Q is on the right side. So they are in different subtrees or in separate subtrees. Now, how can we determine if P and Q are currently in different subtrees or separate subtrees? Since we are searching inside a binary search tree, we can determine the location of the nodes using its values. So for example, if x.val is greater than p.val, then we know P is located on the left side. This will apply. This will also apply to Q. Now, if x.val is less than p.val, then we know P is located on the right side, and this will also apply for Q. Now, a side case we have to handle is what if X is equal to P or Q? Since we are searching from root to leaf, if X is equal to one of the nodes, then the other node must also be in the subtree of X. This means X will be the lowest common ancestor. So for example, let's imagine this node has a value of 2, which is equal to P. And then over here, we have Q here. If we start searching from the root node and we have found P right here, then we know the other node must be inside the subtree of this node. Then we know the current node is the lowest common ancestor because we allow a node to be a descendant of itself. Now let's go over the pseudocode. So we're going to create a variable node to keep track of our current location inside the tree. It'll be initially at the root node. Now, while node is not equal to null, this means we have yet searched through the tree. Now, if node is equal to P or Q, then we know the current node is the lowest common ancestor. So can we just return node? Now, we will check if P and Q are in different subtrees or not. So we're going to create a Boolean variable. P is on left. Then we're going to set P is on left to true if p.val is less than no.val. Then we're going to create a Boolean variable. Q is on left. Then we're going to set Q is on left to true if p.val or q.val is less than no.val. Now, if P is on left and Q is on left. Okay, now if P is on left, it's not equal to Q is on left. This means they're in separate subtrees. This means the current node is the lowest common ancestor. So just return node. Else, we need to search to the subtree where both nodes are located at. Now, if Q is on left or P is on left is true, then we'll set node to node.left. We want to search to the left subtree. Else, we can set node to node.right. If we have failed to find the lowest common ancestor, we can just return null. Now let's go over the time and space complexity. For the time complexity, we get over h, where h is the height of the tree. This is because we search from root to leaf. Now the space complexity will be over 1. Now let's go over the code. So we're going to create a variable node to keep track of our current location. It will be initially at the root node, and then while node is not equal to null, if node is equal to P or node is equal to Q, we have found the lowest common ancestor. We can just return node. Now we're going to create 2 Boolean variables to check if both nodes are in different subtrees or not. So P is on left. P is on left only if P.val is less than no.val. And Boolean Q is on left. Oh, we should say Q is on left instead of Q. Yes. Is on left. If Q.val is less than no.val. Now if P is on left is not equal to Q is on left, this means they're in different subtrees. This means the current node is the lowest common ancestor. So we can just return node. Else, we want to search to the subtree where both nodes are at. So we're going to set node to, if P is on left, then we want to search to the left side. This means both P and Q are on the left side. So we want to search to the left subtree. Else, we can search to the right subtree. Then we can return null if we have failed to find the lowest common ancestor. Let me know if you have any questions in the comment section below.